Hello everyone. We are looking at question 33 of GATE 2014 chemical engineering paper, and the question is: a brick wall of 20 centimeter thickness has thermal conductivity of 0.7 watt per meter per Kelvin. An insulation of thermal conductivity 0.2 watt per meter per Kelvin is to be applied on one side of the wall so that the heat transfer through the wall is reduced by 75 degrees Celsius. The same temperature difference is maintained across the wall before and after applying the insulation. The required thickness in insulation in centimeter is dash. So here initially we have been given a brick wall, and later we are insulating the brick wall from one side, keeping the temperature difference in both the cases same. So we have to find the thickness of the insulation such that the heat transfer of the wall is reduced by 75%. So if we look at this case 1, we have this brick wall, and K we have been given as 0.7, thickness is 20 centimeter. Now in case 2, this brick wall will remain same, and we are adding an insulation over here. And for this insulation, the thermal conductivity is 0.2 watt per meter Kelvin, and its thickness we have to find. Now the temperature difference is same for both the cases. So let's say if temperature over here is T1, here it is T2, then in this case also the temperature in this case here will be T1, and outside the insulation will be T2. So the heat flux, we can write it as Q upon A is equal to delta X upon K. No, not like that. The heat we can basically write it as minus of Ka dt upon dx. So that is, we can write this in terms of delta T upon delta X upon Ka. And this term we call it as resistance. So that is delta T upon R. Okay. Now for case 1, let's just call this as resistance R1 and R2. So for case 1, we will be only having the single resistance, and we can find it formulas R1 is equal to delta X upon Ka. Here delta X is the thickness of the wall that we have been given as 20 centimeter, basically 0.2 meters. On the thermal conductivity we have been given as 0.7. Let's just keep the area as area. Now for case 2, the total resistance will be sum of R1 and R2. It is R1 plus R2. R1 we have found it out as 0.2 upon 0.7 into A, plus R2 we have thickness we have to find. Thermal conductivity we have been given as 0.2 into area. So now we have the resistance for both of these cases. Now in the given question we have been given that the heat transfer to the wall is reduced by 75%. That is, we can also write this as Q2 will be 25% of Q1. That is, Q2 is equal to 0.25 Q1. Now Q2 is delta T upon R and 2.25. The Q1 is delta T upon R1. This delta T, that is the temperature difference across both the cases, we have been given same, so we can cancel that. So that is, we will be having R upon R1 is equal to 1 upon 0.25 is equal to 4. This R we can replace it as 0.2 by 0.7 plus T upon 0.2. This entire thing will be multiplied by A upon R1 is 0.2 upon 0.7 to 1 upon A is equal to 4. This 1 upon A will get cancelled, and we will be having 0.2 upon 0.7 plus t upon 0.2 is equal to 4 0.2 by 0.7. So that is basically 5 times of thickness will be equal to 3 into 0.2 upon 0.7. This will be equal to, thickness will be equal to 6 upon 35. So this will 6 upon 35, it will come somewhere around 0.1714. This is in meter, so the thickness in centimeter will be 17.14 centimeter. So that is the required thickness of the insulation in centimeter is 17.14 centimeter. So we will report the final answer as 17.14.